Welcome back to Vector Valued Functions Part 2. Today we're going to look at limits and continuity of vector valued functions. So let's start with the definition of a limit. For number 1, we have if R is a vector valued function such that R of t is f of t I plus g of t j, then the limit as t goes to a of r of t is the limit as t goes to a of f of t I plus the limit as t goes to a of g of t j, provided f and g have limits as t goes to a. Or 2, if R is a vector valued function such that R of t equals f of t I plus g of t j plus h of t k, then the limit as t goes to a of r of t is the limit as t goes to a of f of t times I plus the limit as t goes to a of g of t j plus the limit as t goes to a of h of t k, provided f, g, and h have limits as t goes to a. Alright, next we have the definition of continuity for a vector valued function. So a vector valued function R is continuous at the point given by t equals a when the limit of R of t exists as t goes to a and the limit as t goes to a of R of t is equal to R of a. A vector valued function R is continuous on an interval when it is continuous at every point in the interval. Alright, let's look at two problems. So we want to discuss the continuity of the vector valued function R of t at t equals 0. So let's take the limit. So the limit as t goes to 0 of R of t is the limit as t goes to 0 of t times I plus the limit as t goes to 0 of a times j plus the limit as t goes to 0 of a squared minus t squared times k. So we get 0I plus a times j plus a squared times k, or aj plus a squared k. R of 0 is 0I plus a times j plus a squared times k, or aj plus a squared k. So r is continuous at all real number values of t, including 0. Alright, determine the intervals on which the vector value function r of t equals ti plus the square root of t plus 1j plus t squared plus 1k is continuous. So first of all, I have f of t equals t, g of t equals root t plus 1, and h of t equals t squared plus 1. F of t is continuous for all real values. It's a line. H of t is a parabola, so it's also continuous for all real values. G of t is the one that's going to be a little bit tricky because of the square root. So square root means the inside, the t plus 1, can only be greater than or equal to 0, meaning t can only be greater than or equal to negative 1. So it's continuous when t is greater than or equal to negative 1. So that means r of t is continuous on the interval -1 to infinity. And that is it.